Mhm. Good day, everyone. So, how are you? Kumusta? Kumusta na? So, today I will discuss about the tree reservoir problem. It's a topic. It's a topic related to our previous discussion. So, this is the continuation of the topic that or the topics that we discussed about fluid flow analysis. So, last time uh, we discussed about um, uh, the friction, I mean uh, major and minor losses due to friction and its application in uh, pipe, series pipe connection, parallel pipe connection, and the pipe networks. So we will apply things that we discussed last time in three reservoir problems. So three reservoir problems is practical problems encountered by almost all water planners. So the term reservoir, it's supposedly it's a tank, but uh, it can be attributed to any water source. So it can be a spring or any different water source that has a particular elevation. So we will just represent mm, the actual condition by this diagram. So we have a tree reservoir with different elevations, so reservoir A, B, and C. Then water will flow presumably from higher elevation to lower elevation. So the um, primary mover of the water in the conduit in this typical problem, in this particular problem, is only the gravity. So from higher elevation, it will always flow to lower elevation. But in this case, between A and B, uh, we do not know. Um, in this particular in this particular diagram, it is stated that the water is flowing from A to D. So we have point A, B, C, and D. But it is always not the case since there are situations that water will flow from D. By the way, D is a junction. Iskina na siya, connector between the three reservoir. There are situations that water will flow from D to A. So musaka siya from D to A. Napay uban, there are situation nga water from A going to D mo down siya. So unsa may reason, what are the reasons why is it that the fluid or the water from will flow from D to A ngano mosaka man siya supposedly mo naog man siya. So there's a possibility if uh, the flow from B to D is too large, dako kay siya volume from from point B to point D, kusog kay siya flow, and ang flow from D to C is dili kayo kusog, or the flow from B to D cannot be accumulated by this pipe, kining pipe DC. So gamay ni siya nga pipe, or it can be gamay siya or dako siya losses, or whatsoever nga mas hinay ang flow from D to C, mas kusog ang flow from B to D. So instead ang water mo flow siya from A to D, so mo flow siya from D to E, musaka siya. Instead nga ang water inig-abot diri sa junction mo naog siya, naay part sa water nga musaka na noon. Okay? So kay since A is low, the elevation of A is lower than B. It's not dili mahitabo nga ang water will flow from D to B since B is the highest elevation. Di mahitabo nga mosaka. So na possibility mahitabo nga ang tubig from D mosaka diri sa A. And wala say reason, there's no situation di sa na mahitabo nga ang C from water from point C mosaka sa D. So it's not possible. Ang possible ra is ang water it's either A to D or D to A. So kanara silang duha. Okay? So ang buhaton na to ana to determine kung asa ang direction sa flow. I mean, in the first place, why do we need to determine the direction of the flow? Mamatter man gud na because if we will sum up all the liquid, possible man gud nga kung ang water mo flow from A to D. So moingon ta for example in this kind of diagram. So based on the direction of the flow, we can say that the Q at C is equal to the Q of A and Q of B. Di ba? So in this particular diagram, we can say that QC is equal to QA and QB. It's possible po if we can determine the direction of the flow, kung ang direction of the flow is from D to A, mabali siya, mosaka siya. So maingon ta, QB, Q sa B is equal to QA and QC. So malahi na sad ang equation. Then it will greatly affect the 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 figures or the value of our answers. So mana nga in the first place we need to determine asa ang direction sa water kini nasa tunga-tunga nga reservoir. Kung same sila elevation, wala nilain. Adto dyan na padung. But nani sa ubos, nani sa tunga-tunga, mo ni ang problem. So, yeah, as I've said earlier, the reservoirs merely represent the sources of water that are applying a certain fixed head to the system. So, it is obvious that the water will flow from the reservoir with the higher elevation or heads towards those of lower heads. So, man akong giingon before. So, the solution is one of trial and error using principles of energy and continuity. So mahog dyan siya nga trial and error because since wala man ta kabalo sa direction sa water from A to D, ang atong buhaton ani is atong i-assume, we will assume that the water from A to D is not flowing. So unsaon man nato pag-assume that the water at this example naman ni. Unsaon man nato pag-assume that the water in this pipe is not flowing. So we will assume that the head or the water, if not let's say piezometer, we will assume that the water at D or the pressure or head elevation or head the water at D is equal to the elevation at A. Okay? So kung ang mahitabo gud ana if the water elevation or the water head, pressure head at D, kung ang pressure head sa D is equal sa C, equal siya sa level siya sa C. I mean, not C, A. Kung level siya sa A, so it means to say that water will not flow either from A to D or D to A. Okay? Balik ko na ko ha. So, in order to determine what type of equation, di ba? Naman to equation ganyan na nga kana. Wa man ta kabalo. It's either QC is equal to Q or plus QB or kung ang water from D to A, so mahimo siyang QB is equal to QC plus QA. Wa man ta kabaloan na sa ang direction. So ang atong buhaton is dili na to siya palihokon ang water from A to D. So to do that mathematically, atong i-assume, balik ko na ko, we will assume that the pressure head at D is equal to the elevation at point A. So kung naa diri ang imong pressure equal sila, dili mo flow ang tubig from A padung to D. Dili sad mo flow ang tubig from D to A. So unsa na may mahitabo ana? Tanang water supposedly in our assumption tanang water from B mo flow sa D, then from D to C. And then ato na siyang i-compare. We will compare the Q of C sa Q sa B. Okay? So kung equal, if the Q of B is equal to the Q of C, sakto tinuod atong assumption. Tinuod atong assumption nga there's no water flowing at pipe A. Pero if let's say if QB pipe ino na nato nga pipe B, pipe A, pipe C. If water at pipe B or the Q of pipe B is ano man to? Okay. If the wala. If the uh, Q at pipe B is less than Q at pipe B, meaning mas dako C, meaning mas dako ang Q ang discharge sa C kaysa B. So, unsa may pasabot ana? Mas dako ang flow ani kaysa sa flow sa B. Meaning, naay ni contribute, meaning ah ang A ni flow padung sa D. Okay? If lahi sad ang situation, um if ang flow at pipe B is greater than C, mas gamay ang C, mas dako si B. So ang flow sa water ni ana ngadto ni flow from D to A. So ang water ni flow from B human D human ni adto didto. Some of the water sa B ni saka ngadto sa A. Wa siya ni down tanan didto. Okay mo na atong assumption. First ato ni siyang i-let the Q of the middle reservoir, middle pipe connecting to the pipe connecting to the middle reservoir as 0. Then, in that way, makadetermine ta kung asa pa daw ang flow sa liquid. So, kung ma-determine na nato, ma-establish na nato ang equation, then we can now apply um, the solution using this equation. Kato atong gi-discuss last time. Okay? So, mana siya the solution proceeds by assuming that pressure head at node B, which is then leads to the computation of the allowable head loss. So, na naman in this case na naman tay head loss because naman tay value sa iyang reservoir. Na natay value naman ay fixed nga elevation or if dili gani hatag sa problem fixed nga elevation mo na ang gipangita mo na ang unknown. But most problem and in fact sa actual mao man we can measure the value of the elevation sa different reservoir. So naa na tay head loss, so from um, B to D, so level man ni siya, so naa na tay head loss from B to D. That is the difference in elevation from B to D. Okay? Then naa na tay head loss. So maka-determine man ta sa value sa F using the Moody diagram. Then we can now determine the Q through this velocity. Okay, so kung maka-determine na ta sa Q, mo na siya. Usually ana ang for this kind of problem, ang atong i-determine is ang kuan man ang value sa iyang discharge. How much is the value and asa ang direction sa discharge. Okay? So we will solve an example. In this case, I will just share the example nga nasa book. Although it's fine in the book, you can read it in the book. Ako lang i-discuss. I will discuss the solution at the book. I will share screen the book. Yeah, okay. So we have this example. You can find it in the book, page 237. Ako lang i-discuss, ako lang ipasabot. So we have these 3 reservoir shown in the figure, and they are connected like this one. Actually, mao na siya. So reservoir A has an elevation of 110 feet. Then reservoir B has an elevation of 120 feet. So mas taas si B, mas ubos si A. Pinakaubos si C, which has an elevation of 70 feet. And then nani siya ay connector junction, what we call at point D. And then From A to D, it is connected uh, with a pipe with this material, cast iron. It has a length of 750 feet. It has a diameter of 8 inches. Okay. Then from A to D, so cast iron, 12 inches, 1,000 feet. And then from D to C, it is connected with a pipe, um, galvanized iron, 6 inches in diameter, and the length is 500 feet. So ang problem is we need to determine the Q, the the amount of water flowing along this pipe, and asa sad ang direction. So in this particular problem, since this is the highest reservoir, we know for sure that the water is flowing from B to D. B to D, kabalo ta kay mo man ni pinakataas. So there's no other way to flow pa doon sa ubos. And also, at point C, or pipe C, we know that the direction of the flow is, for sure, we know that the direction of the flow is from point D to point C, because point C is the lowest uh, elevation between the three. So from D to C, always na mo flow diha. What we do not know is the direction of the Q of this pipe A. O kabalo if it's from D to A or from A to D. Okay? So, as I've said, we must first assume that the flow in this pipe A, this is pipe A, is 0. So, we can do that by, mati akong giingon nga, assuming a certain, ano ni? Assuming a certain, saan man ni? Ang gisuwatan. Assuming a certain water elevation na tupong sila diha. Mo na ang pressure head or ang equivalent nga height sa water at D. So in that case, water from A to D will not flow. So mahitabo ani is naatay head loss kintahay. Naatay since the elevation at point D, the elevation of water at point D, or yung equivalent pressure head is naman sa 110 feet. Equal man sila. 110 feet. So ang head loss from B to D is 120 minus 110. So that's 10 feet. Then ang head loss from D to C, so 110 minus 70, so that's 40 feet. Okay? So na solution diri ang i-discuss. Okay, so ingon siya, the technique that is commonly employed is to assume that the head at D is the same as the middle reservoir. Yeah, man atong gibuhat. Thereby cutting the flow from that direction. So the other two discharges are computed and compared, and then the appropriate adjustment to D can be made. So ato ni siyang i-compare ang flow sa B and C. Then atong i-adjust ang iyang elevation. Kaya wala kabalo. So ato lang i-assume nga 0. So the difference in elevation from B to D, 10 feet. From D to C, that's 40 feet. So asa man nagikan ng 40, that's 110 minus 70 sa elevation. And then, na naman tayo elevation. So we can now use the Darcy-Weisbach equation. F times length over D, then V squared over 2G. If we can compute V, so we can now compute Q. Okay, so we have 1 foot at 12 inches man, then 1,000 feet, and V squared over 2G. So simplifying, so we have this equation. F V squared is equal to 0.644. So you can compute that one in your calculator to verify. So similarly, if we will apply this to C and D or D to C, so we have 40 man ang ilang difference. So 40, so 500, that's the length over diameter. So we can have this relationship. F V squared equal to 3.43. So wala pa ta kabalo sa value sa F. Kay as you know, to know the value sa F, to determine the value of F, we need to use the Moody diagram. If it's not given, kung dili siya given, if it's not given in the problem, we need to solve the, determine the value of F. So we can, ito ang method to determine the value of F. First is to determine the Reynolds number. We can determine the Reynolds number by, ito naman the equation sa Reynolds number, gidiscuss na to na before. And then for cast iron pipe, this is the roughness element, cast iron pipe. Then we can solve for roughness over the diameter. Then if we will plot it in the Moody diagram, ato man ang gidiscuss before ang Moody diagram, we can estimate that the value of F is equal to 0.02. Okay, so by the way, ang Reynolds number is dependent na siya sa it depends on the velocity. Okay. Ano velocity. Kuan na Reynolds number is velocity times the diameter over kinematic viscosity. Or pwede po itong density over dynamic viscosity times d times the velocity. Actually, in this solution, gi-assume niya nga ang F is 0.2. Then gi-assume niya nga ang F is 0.2. Iyang gi-check. Now, checking this assumption for water temperature nga na siya, then na-solve niya, na-found out niya nga ang value sa sa F is roughly sakto ra sa ang assumption 0.02. Kaya remember, ang Reynolds number is dependent man on the velocity, di ba? Depende siya sa velocity. So, to determine the velocity, kung ta kabalo, so mag-assume lang ta mag-assume lang ta og velocity nga 5 points. Actually, di man i-assume, computed man based on this assumption 0.02. So, gi-check niya. So, ingon siya nga more on sakto-sakto ra sa nang akong assumption nga 0.02. If money ang buhaton, actually if the friction factor is not given, which is mao ni siya sa actual ang buhaton. Dili man given usually ang friction factor. Although naanay table ana based on the velocity ana, pero for raw solution mo na nga mag trial and error. But anyway, pwede ra man na siya buhaton gud nato sa Excel. So ingon siya, so our assumption is valid. So sakto day ang assumption nga 0.02. So now we can compute for the Q. Kaya na naman tayo velocity nga 5.67 feet per second. So multiply sa area. So nanatay discharge sa pipe B. And then similarly mo na atong buhaton sa pipe DC kini. Mo na atong buhaton diri nga pipe. So same method. Same method, mag-assume ta og value, sa F. Then atong i-check based on the Reynolds number, i-plot na to sa Moody diagram. Then na-found out niya nga ang FDI is 0.019. So 0.019. So di ang iyang assumption at first good for DC is 0.02. That's the first assumption. Then the solution found out that F is equal to 0.09 when he plotted it in the Moody diagram. So i-solve niya ang velocity based on this one, 3.43. Then nakakay velocity nga 13.43 feet per second based on this value, 0.019. So you can already compute the Q, which is 4.69 cubic feet per second. Now, nanaman tayo Q, 4.69 and sa tong usa ka Q. Usa ka value sa Q is asa raman to? .45 dara. So, ang mahitaboan ni mas dako ang value sa BD or no, mas dako ang value sa kini CD. Naingam siya ang CD is 4.69 cubic feet per second. Ang BD is 4.45. So, ingon siya, we see that according to the book, it says that QDC, kini DC, is greater than QBD. Mas dako siya. So, maunsa naman ni ron kung mas dako ang value sa pipe C. So, ang mahitaboan ni this one, mas ubos ni siya. The elevation of this one is it must be slightly lower than 110 feet. So it should not be above 110 feet. It should not be equal to 110 feet. So based on our checking, mas dako man ang dito C, mas ubos ni siya. So it means since the elevation head at D is lower than 110, so the water is flowing from point A to D. So actually mo to mao na purpose why we had this checking kini nga pag-compute na to pag-check in order to know the direction. So the direction di ay is from point A to point D. So na-solve na nato ang first phase sa kuan. Na-solve na nato ang first phase sa problem to know the direction. So the direction is A to D, B to D, then D to C. So karon ingon na siya giubos niya ang head to 109.5. Actually kining 109.5 assumption na sad ni siya. I mean trial ni siya mura bag first. Okay, first trial. 109.5 kay less than kuan man. Less than 110. So mas ubos siya sa 110. So any value less than to 110. So iya lang gi gamay og kuan. Gamay og ubos niya 0.5, 109.5. And then based on that assumption, figure sa value sa elevation, na siya different head loss. So instead of 10, so nahimo na siyang 11, din kini siya 0.5, then 39.5. So mo na ni ang mga head losses based on this elevation first trial. Okay, then apply na sad same procedure. As before, katong gibuhat, katong assume the value of F, and then based on that value sa F, we can solve for velocity. Then after solving for the velocity, we can solve for the Q. Then we can solve for the Reynolds number. Then kung ma-solve na nato ang Reynolds number, we will plot the Reynolds number to the Moody diagram. Then verify the value of F. So if we can verify the value of F, so mana na to ang value sa F nga atong gamiton so that we can solve for the velocity and then solve na po balik sa Q. Okay, so balik-balik na dyan na siya, balik-balik. Mo lagi, as I've said, it's better nga gamiton ni siya using an Excel spreadsheet kay kung mano-mano, tugay kay sa buhaton. Okay, so kani in this case, iyan na lang gi-plot para di siya maglibog ang libro. Yan na lang i-plot. And then, to check the assumptions, as I've said. So, based on that, naa siya kuan, using the value for F, we obtain for ED, so Q, 0.39. Gi-check niya, then gi-sum up niya ang discharge na ay naikida nga 0.29. So, this computation, kini nga assumption diri, it shows that there is too much flow coming from D to C. So dako ra kuno kaayo ang line gid siya na may say sobra naman siya kida nga 0.29. So ingon siya, we have lowered the head at D too much. So ubos ra, so i-adjust na instead nga gisaka na sad niyang balik, instead nga 109.5 ihimo niyang 109.9 feet. Kining 109.9 feet, it refers to the elevation diri sa D. Ganina kay ubos ra kaayo katong 110.5. So naa siya kida nga 0.29. So iya na sang gisaka og balik gamay, but not equal to 110. Ubos lang gamay sa 110, which is 109.9. And then gibalik na sa niya og solve. Based sa kato atong gi-discuss ganina, solve for assume the value of f, then solve for v, then after solving for v, solve for the Reynolds number, then after solving the Reynolds number, plot it in the Moody diagram. Then after plotting the Moody diagram, we can determine if sakto bang imong assumption sa f. Then kung sakto siya, then use that value of f to solve for velocity. Then after solving the velocity, you can solve for q. So mara na siya balik-balik. So ingon siya, kini mo na sa ni mana akong gi-discuss ganina balik-balik. So iyan na sang gisum up ang discharges. So gamay na lang ang kida, 0.05 cubic feet per second. So siya ingon ang libro, we conclude that this is close enough kay it's kuan mo god, it's not practical nga ato jud siyang iigo sa zero jud ang iyang kida, ang iyang difference. Di naman siya in terms of engineering application, it's not practical. So anang close lang enough nga allowable nga error. So actually, the solution of tedious iterative problems such as these are facilitated with the use of computer spreadsheet such as Excel or okay ba ning Corel 4. Basta any spreadsheet, actually you can download free spreadsheet. In fact, mao ni akong gigamit, di ba? So far, pantay mo nga, I'm not using a PowerPoint, so I'm using Libre. Actually, Libre is similar to na siya sa Microsoft. Same na siya og capability na alay very few, very small nga kuwang siya, but it's always catching up. So mana siya, it's better nga you will plot it using this one. Actually nahitabo to siya nga nagbalik-balik because in this problem f is not given. So man dili man gihatag ang f. In most problems gud kung makabantay mo, if you observe problems in the book or reviewer or other sources, other references, other examples, maybe in other instructor, f is given, gihatag na. Pero ang problem gud sa actual, kabalo, we do not know the value of f, and in fact, technically f is dependent on the value of the velocity. So depende maguna if mo change ang velocity, mo change ang value sa f. Actually, we discussed that one last meeting in plotting of the Moody diagram. Okay, mo change ang velocity, Reynolds number will also change, and Reynolds number is one of the determining factors in solving for or plotting the value of friction factor f. So actually sa actual mao ni siya kini atong gi-discuss karon, mao ni siya ang usual nga buhaton sa actual. Okay, so ingon siya, in this technique, taas-taas siya, the computation for the first trial were set as shown the four lesson. First error ko no is 0.239 cubic feet per second, so mas dako ni siya nga error. So lain na sad nga trial. Actually kung mag-Excel ka, pwede raman imong sayon raman kay pwede raman imong imong butangan imong kida ba. Instead nga 110 ubos siya 109.9, 109.9, 109.8, 109.7, imo lang siyang tan-awon ang tanang mga figures. So mo na siya sa actual actually. Similar with other subjects also in fact in earthquake engineering, in concrete design, even in steel design, mausad na superficial ra mga if you can observe sa school marag superficial ra kay ba nga tagaan lang kag value mo gawas lang na ditso dayon. In fact sa actual sulbo na to na nga mga value. For example in our earthquake engineering, so based on any CP na atay value sa R, di ba? Sa linog-linog ba sa R, depends on type. Sa ato gihatag na sa National Building Code of the Philippines, but sa actual ana if you study advanced earthquake engineering, sulbon dyan na siya din. Taas-taas na siya nga solution ng value sa R. It depends on the type of framing and the type of framing construction material. And the type, depende sa na siya sa height from the ground to the upper portion sa imong frame. So, in fact, sa other subjects pod, sa babay subject nga usually mag-trial and error ha. Even in economics, even in estimates, even in soil mechanics in your geotechnical engineering. So if you solve for the value of the settlement sa clay, sa yuta, usually trial and error na taas-taas na siya. In fact, you will use regression analysis. So other subject pa nga usually mag trial and error. Actually sa design actually sa design kuan na siya. In fact when I design at first before mag trial error pero karon gud kay usually di na ko kuan na lang first trial and second trial kay marag na memorize naman usually ang kuan given the load, given the distances, given the height, so ma-memorize na nimo pilay dimension sa beam, pilay reinforcing bars ang gamiton. So i-check na lang nimo kung sakto ba imong assumption. Kung dako ra gani kayo imong pagamyan, kung gamay ra gani kayo imong padak-an. So ana alam murag maximum of 3 trials lang. Mao na siya kuan. And mao na siya sa actual. In fact, kasuway ko ani og kuan I was commissioned before 5-6 years ago na nag-design og water supply system sa Bohol. Then actually it was a consultant firm, then ilang gipa-job out kay murag kuan na siguro. Daghan na siguro silang gibuhat, ilang gihatag nako, then mana inana same ana. Actually it was more complicated and more scope pero naay portion nga na kuan na kini atong example karon mo ni akong gibuhat sa Bohol. It was in Garcia Hernandez man siguro to, sa naman ay bukid diha sa part sa Bohol, then naay mga springs, then naa sila similar ani naay mga sources of water, na sila spring, then ilang gi-connect ang spring with each other, then ilang gi-channel nga tupadong sa barangay. Sila tangki sa ubos, then I did similar to this analysis. So it's first trial and error. Nangayon lang kog data nila. Ano ko ni adto mismo. Okay? So that would be all for our discussion. You can read actually I'm giving you an assignment to read this one, the entire chapter. Kuan ra man ni, murag pila ra ni ka pages. In fact, most of it gidiscuss naman sa din nato, like this one, minor and major losses in the pipes. We already discussed this last meeting, so you must read this portion here. Then I think naani portion diri wa na ko na discuss, then kamo na lay read ani. I will leave this up to you. Kini siyang pressure surge in pipe closure or in water hammer. So naani sa tumoy, naani nga topic. It's a relatively easy topic compared sa other sa other subtopics. So relatively easier ni siya nga subtopic. So kamo na lay basa ani niya. It will be included in our midterm exam. So we'll have our midterm exam on Wednesday. In fact, tanan na tong gidiscuss so far apil na sa midterm exam. So this one, transient flow in closed conduits. Actually, ko ani siya, it talks about water hammer. So kanang mag-close ka sa imong faucet. If you'll suddenly close the faucet, na siya gitawag og water hammer phenomenon. Na siya sudden surge sa pressure due to sudden stoppage of water velocity. Na siya gitawag og back pressure o propagate. So there's an increased pressure that propagates back to the pipe. Kamo na lay basa ani niya then ani siya example sa tumoy. Okay, so that would be all for our discussion today. So good day everyone. Thank you for your attention.